the ability to communicate, right? So one of the quotations that's always been a favorite of mine is from George Bernard Shaw, and he said, the problem with communication is that there's always the illusion of it happening, right?
Okay. Yeah.
So you can look somebody right in the eye and tell them, and they can nod their head, and they had no idea what you said.
Exactly.
But so to be a better engineer than not means that you put the information that you need to communicate down in a method that's easy to understand,
Sure.
right? And if it's easy to understand, then it's easy to follow.
Welcome to the podcast here with Mr. Michael Etheridge, the senior design engineer at Wylie Manufacturing. So, kicking things off, can you give us a little backstory about your early life, where you grew up?
Sure. I was born in Beaumont, Texas. My dad worked as a petroleum engineer for Exxon.
Okay.
So we moved around quite a bit. My younger brother was born in Midland. I went to elementary school in Oklahoma City, junior high in Corpus Christi, and high school in Tyler. And right after I graduated from high school, my parents moved down to Houston.
Okay.
And they lived there the rest of their lives. And then I went out to Texas Tech to go to school in Lubbock. So.
Okay. And what'd you study at Tech?
Mechanical engineering. So I've got
Okay.
a bachelor's degree in mechanical engineering.
What was involved in that degree there?
Well, I squeezed my 4 years into 5.5, but there's a lot of math involved, 3 semesters of calculus, 2 semesters of differential equations, things like chemistry. You got to take the basics like government and those kind of things your first
Sure.
couple of years. And then you get into design courses in the major portion of your degree program, whether it's heat transfer, thermodynamics, design project classes, those kind of things.
Sure.
Physics, all those. So.
The whole roundup then.
Right. You got to love the math.
Yeah. Well,
For sure.
that's definitely one that a lot of people aren't usually going to do math.
Right.
Just to have to do math.
Yeah.
Definitely. Okay, so from my understanding, you worked at a oil manufacturing company in Levelland?
Yeah, an oilfield manufacturing company that built acid and cement equipment for oilfield service companies like Halliburton, BJ Services, Baker Hughes, Schlumberger, those kind of people. I had to figure up the costs and then create the drawings and details it would take to, physically produce 5,000 gallon acid transport.
So on the drawings, did you use some sort of program or
I used AutoCAD.
AutoCAD? Okay.
It's more of a drafting tool. Nowadays, I use a more sophisticated 3D solid modeling program called Autodesk Inventor.
Okay.
And that allows me to design things in 3 dimensions and visualize how they're going to move with relation to each other. Where AutoCAD, you lay it out as a line drawing, in
Sure.
in flat XY dimensions, which made producing multiple views of parts challenging because you had to just project the geometry and it just took a lot of time.
Right.
I'm thankful for modern software though.
Right.
So.
Did you ever have to do the old-fashioned way with pen and paper?
I did. My very first job, for 6 years, I worked at a heat exchanger manufacturing company. And when I was hired on, they walked me into the room where I was going to be working, and it was a room full of cubicles and people. And they said, "This is your drafting table. and you are going to draw heat exchangers and lay out tube sheets and tube patterns to scale by hand on a drafting table. So for a couple of years, my very first job, I did drafting by hand, and it was all, with a pencil and a ruler and, swinging arm, old-fashioned drafting table.
Oh man, yeah, I did. I learned how to do that, but I can't say that I did it very successfully.
Yeah, that's hard. That's hard to do. It's challenging.
Yeah, a lot of math and straight lines, and
you got to anticipate where you're going to draw, because you're actually putting a pencil to paper and you're consuming the paper as you do it. So
absolutely. Well, so from Levelland, what got you started with Wylie?
Well, so the oil field is a very cyclical industry. There's booms and busts that happen regularly.
Right.
And over the course of my 19 years in the oil field related manufacturing, there were at least 5 busts.
Oh man.
And really 6 if you counted the last one that I got out of before we slid into. And the problem, of course, is that when it's booming, you can't ever catch up. And when it's bust, well, then you're outside picking up rocks and painting rocks or whatever it takes to stay busy.
Right.
Like we would repaint the shop floor, every stripe, sweep everything, organize everything, just stay busy. And but there was no overtime.
Right.
And I wasn't paid hourly, but the guys in the shop a normal week was 50 hours a week. And so when you take somebody down from 50 hours a week to 40 hours, that 10 hours of extra work that you're getting paid for 15 hours worth, it's a big pay cut.
Yeah.
And so it was, the downs were just very stressful.
Right.
And I got really tired of that kind of up and down cycling. And there's a lot of stress whenever we slowed down, because you didn't know if you were going to be able to keep your job.
Sure.
And it was just a lot of stress. So I looked for an opportunity to change careers and found it with Wylie.
Oh, okay.
Yeah. So I went from the oil field to agriculture.
That's a interesting shift there.
It was.
Was it a bit of a shock?
Yeah, it was. But it's the agricultural industry, the people are a lot more down to earth.
Sure.
Like all the time.
Right.
Like just everyday people. The oil field is typically driven by either greed or fear. And you're never in between. And so when it's good, people are greedy, and when it's bad, they're fearful. And it's just a case of extremes.
Yeah.
But agriculture is not so much that way. So I really enjoy that, and Wylie has the best people that I've ever worked with, for sure.
Yes, sir. So what was the first couple of years coming on board like? Were you?
Well, when I first started, there was a couple of projects that we did. One was with we came up with a vineyard sprayer. We invented our own vineyard sprayer. That was my first design project. And it was a complicated little project, because you're trying to find a way to propel enough air into a box and back out of the box so that it comes out equally from top to bottom in an opening this wide, equally at 80 miles an hour while it's spinning, and you got to gasoline engine turning a big fan that's really heavy at 3,000 RPMs. And it was just a really good challenge to learn from. And the second one was the spray loop system, which is in our catalog. And I actually, that first year, took my first ride in a tractor.
Oh, okay.
And I never had been in a tractor before. And so I got in a case tractor with a 108-foot boom attached on the back, spray wing 2, and the farmer, his name was Galen Stuckey, and he turned on the GPS and lined up the tractor with the row, and we were going around a pivot, and he took his hands off the wheel, and the tractor drove itself in a perfect circle with the wheels in between the crops. And I was like, this is amazing. And I was like, and there's a 108-foot boom, just swinging out there, and we're spraying his crops. Sure. And using the system that he helped us come up with. And I was like, this is fantastic. And so I was hooked.
Right.
So.
Never looked back since then.
That's right.
Yep.
No regrets.
Well, on creating equipment, what's the difference between designing something that works versus works in the field?
Well, in the when I was working in oilfield manufacturing, we had a consideration that we called the Bubba factor, and that was that the hands that were hired hands, they didn't own the equipment.
Sure.
So they didn't necessarily have a personal investment in it, which means they didn't care about it. That meant that you had to make it tough enough to stand up to abuse, right? You didn't want to make it so heavy that it was impossible to use, but you had to overbuild it,
sure.
Right? Design it to be heavy duty and to suffer some abuse in order to last a while. So that's something that works in the field. You can design something that works if you know it's not going to be abused and make it as light as possible.
Right.
You can put aluminum tailgates on pickups, but just drive around and see how many dented aluminum tailgates you got.
Right.
They're all over the place. That's not the best design.
Right.
That's a difference to me. That's one example.
So Wylie, you mentioned the ag equipment earlier. Wylie does the sprayers, of course, that's our roots. And,
yes.
I'm sure there's a lot to unpack as far as sprayers go. But we also do the industrial equipment, such as water trailers, pressure washers, things like that. Is there a difference in one versus the other and how you approach designing those?
The main difference between the two is not so much there's a lot of details in both, but there tend to be more moving parts in a sprayer.
Okay.
In other words, a sprayer has to be able to tilt and to fold over and to fold in, and those kind of geometric considerations are not so essential on a trailer. The geometry has to work physically on a trailer so that the weight is balanced, for example, but there's not a lot of moving parts. I mean, the parts that move are parts that are designed to rotate, like engines and pumps and that kind of thing, and valves that either are electronic or hand controlled, but parts that they don't move with respect to each other. So that kind of is a primary difference.
Right.
There's just a lot of assembly of steel parts on a sprayer that isn't necessarily the same as on a trailer. You got a lot of parts that clamp together and then they're there.
Right.
Does that make sense?
Yep.
Okay.
Definitely. So on sprayers, you mentioned that they fold and things like that. When you're coming up with a design, so to speak, for a sprayer, how do you keep in mind all the moving parts like the tips, the wires, and the whole shebang, all the way across the boom?
Well, in most cases, the weight of the boom itself is substantially more than the weight of all the little minor attachments, such as the plumbing, the spray tips, and those kind of things. It's always good to go see something that works, and if you can say, well, that would easily get torn up, right? Then you have a chance to do it a little bit differently, right? And you can do what you need to change it up design-wise to protect those things that are easily breakable.
Sure.
Does that make sense?
Yep. Okay. So what about water flow? I mean, I know with spray tips, I was talking to Aaron Miller, I believe, over at T-Jet, and there's like so many different, methods or different droplet sizes and all this stuff. Is that a factor that plays in when you're building out?
For me personally, no.
Okay.
I just get into the structural part of it, and I have to make sure that it's strong enough to perform its function. But the plumbing application, there's so many options, right? I mean, you can have a standard water trailer frame, and we've got 100 different frames, right? But there's 100 different ways to plumb each one of those 100 different frames, right? So that's 10,000. So I don't get into that level of detail, right? I just mainly worry about the mechanical part of it.
Okay. So designing for those plumbings, do you build it with the assumption that there might be something that comes out that may or may not work on it?
Well, I don't like to assume things,
right?
Because that usually gets you in trouble. So what we often do is in the shop they'll mock something up, manifold or something like that, and they say we need something or some way to be able to hang this, and then it's my job to measure and make sure that we got the mounts appropriately spaced and adequately sized to hold that structure.
Sure.
But there's always 6 ways to skin a cat.
That is very true.
Right.
Very true, especially in designing something.
Right.
Oh yeah.
The options are wide open.
I run into that consistently.
Yeah.
So people always market and they say, our products are durable. That's one of the biggest catchy headlines. So when we say it, though, it's true. What makes ours true in a way?
That's true. We're not doing it the cheapest, but we're building stuff that we know stands up to rigorous use, right? And you can't account for every possible scenario, but you can account for most of the extremes. And you don't want to build something as cheaply as you can, because if it doesn't last, they're not going to buy another one, And
sure.
Our stuff is a little overbuilt, but it's not so overbuilt that you can't afford it.
Sure.
Right. So it's sometimes you got to walk the line a little bit, making design decisions. You want something that's strong enough to stand up to going over the bumps in the pastures, but maybe it's not designed to take the corners at 80 miles an hour.
Well, right. You would hope nobody would actually do that,
right. But
you'd be surprised.
Yes.
Absolutely. Well, okay, so you mentioned overbuilding, but not to the point where it's not affordable.
Right.
If it gets a little over the line as far as cost, what do you sacrifice to kind of keep it level?
Well, from that standpoint, I'd say you're talking about a deluxe sprayer versus an economy sprayer.
Okay.
Right. So you've got sprayers that fit on, 100-gallon 3-point mount, but you can't put a Spray Wing 2 on a 100-gallon 3-point mount.
Sure.
Right. So it's hard to get premium features for an economy price.
Right.
And it's hard to sell economy features at a premium price.
Right.
So, if that makes sense.
Yeah.
That's just kind of a balance. Like, that's why we make a range of sprayers.
Okay.
From really affordable to really premium.
So in that vein of thought there, we have several like UTV sprayers and things like that from an outside perspective looking in, it might seem like they all do the same thing, but what makes all these, 100-gallon sprayers like a power sprayer different from a UTV sprayer or things like that?
Well, sometimes you're just changing the structure up so that it can fit where it needs to go.
Okay.
Like, a skid would fit easily on the UTV, but you need a skid with legs to put it on 3-point because you got to set it down on the ground, pick it up from time to time, and you need to be able to do that easily, right?
Right.
So sometimes you just need a boom buster and you need to plug it in on a receiver hitch, right? And
Sure.
so that's just a sliding, bracket that simple is good for what it is, right?
Right.
You don't need the complex folding, tilting sprayer.
Sure.
You just need to fold it out and go use it.
Well, you said simple is better. I do agree with that fully. Is there some things you've seen out in the field that you just immediately know they've put way too much on there?
Well, I mean, some of the self-propelled sprayers are more complicated, and the geometry is just intentionally complicated, but they have multiple folds. And when I say multiple, I mean more folds than what we would incorporate.
Sure.
Right. Sometimes the wings fold in twice, where ours just folds in once. Ours might have an outer fold to fold in half, and then an inner fold to fold the wing in.
Sure.
Where something that has a really long reach, say 120 feet or something like that, might need to fold in twice and then fold the whole main structure in to get it clear of
Right.
what it's doing. And so it becomes more complicated, but there's a reason for it to be complicated, because you again have to pull that thing into a building somewhere and get it stored, and you can't just do that if you can't fold it.
Sure. So how do you gauge the weight distribution? So if someone's going to use it for a pasture, you obviously have to consider compaction. And
well, that's in that case, you're just choosing between something that might need a wider spread of an axle, bigger, wider flotation tires, and then the compaction, right, doesn't become a problem because you're not going down a row. You don't have to have a narrow track, or I should say a narrower tire. You can have a big, round, knobby tire that doesn't mash everything flat. And it's,
right.
But if you're doing row crops, then a tractor tire suits its purpose well because it you have traction, but you're not trampling the crops because you're able to track in between them.
Right.
So that's, I don't know if that directly what I'm concerned about, but that's just an example.
Right. So the different boom lengths, I mean, why not go for the biggest one all the time or the widest one all the time?
Not everybody has flat level ground like we do in West Texas.
Okay.
Some people have tiered, the land is tiered, and they may need to they only have, say 60 feet plateau to work with on level ground. So if their boom is wider than that, then they can't ride it level to the ground, and therefore it just won't spray as efficiently.
Right.
And so that's why it's often the case why people buy shorter booms. Out here, you see land that's laid out in sections, square miles.
Yeah.
County roads being a mile apart, east from west and north from south, and there's no obstructions. It's just wide open spaces. But in a lot of places, they may have a 2 or 3 mile long field that's really not all that wide, and so they don't need to spray 2/3 of it on one pass and then only a third on coming back.
Sure.
That makes sense.
Yeah.
So efficiency and purpose fit into how you're going to use your boom.
Okay. What about saving as much chemical as possible? Is that something that you consider when you're putting something together?
Well, I think that that probably goes more into the spot spraying, like that Weed It rig up there.
Right.
That's a great technology. It's a genius way to save chemicals, because that's a big expense when it comes to sprayers.
Right.
Chemicals are something that you consume on a regular basis, and there's a lot of effort and research and time that went into those things.
Sure.
And so that precision spraying technology is a big advantage that we've gotten into in the past few years. But
Okay.
It's not really I have to design around it. I have to consider it. Like I may have to build shields for the sprayers and sensors, that kind of thing, but not necessarily I'm not inventing the technology.
Sure.
If that makes sense.
Yeah. So what about that precision spraying technology? How does it work?
Well, basically, you've got lasers that tell you where you're sensing, and then you've got infrared sensors that are basically sensing the presence of water or moisture in a plant. And the working theory is that if a plant has moisture and it's not supposed to be there, that's a good spot to spray.
Right.
Right. So you should have plants in the rows, crops in the rows, but nothing in between the rows.
Right.
So if you're seeing things in between the rows, that's where you got to spray. But you don't have to spray everything. You just you identify that spot with that infrared technology, and then a little directed spot of chemical, instead of wasting 90% of it.
Right.
That targeted application saves you that 90%
Right.
cost.
Yeah. Absolutely.
Right. Now, there's an investment that you have to do up front
Sure.
to get that targeted efficiency, but over time it pays for itself.
Yeah. Okay. So in a way, spot spraying or precision spraying is probably a better method, even if it's like you said, an investment right out of the gate.
Right.
Gotcha. So what about the Versatrail that we just built, the dual precision?
Mm-hmm.
So that can do both, right? It can do the broadcast
Yes.
and the spot. Okay.
Yeah.
So how is it able to do both?
Well, because you've got a what we call a dry boom. That is to say, it's on demand, and then you've got a wet boom where the fluid is under pressure, but it's released only when it's needed by the individual solenoids when they're activated by the detection system. So from that standpoint, when you're broadcasting, everything's open until it's closed. And
Gotcha.
you're just spraying for weeds until they're gone.
Gotcha.
That makes sense?
Yeah.
Okay.
So it's basically, it's not two individual booms then, is it? It's just one boom, or one strip, I would say, that's got tips on it.
Well, you have, each boom has different sections.
Gotcha.
Say like on the spray wing 2, you've got 5 sections. You got your center section, each of the primary wings, and then the secondaries and breakaways sometimes are combined. You could have 7 sections if the breakaway is treated separately. But you can either spray per boom or, per section, or just open them up.
Okay, so that's that sectional control that is integrated into it. So how do you design that feature in there?
That's a good question, and I don't have the answer to that. That's a lot of technology.
Okay.
And I don't delve deep into the technology side.
Gotcha.
No
worries.
More in the mechanical side.
No worries at all. Okay. Well, so is there any regulatory factors that play in, or any regulations or anything environmental that you have to consider?
In terms of compliance to legal requirements, when we manufacture DOT vehicles that are designed for over-the-highway use, they have to be properly lighted, properly marked. They have to have the right information on the VIN tag, tire placards, conspicuity tape, all those things that go into it. For non-DOT applications where there's no lights required or fenders, or they might not even have a VIN tag on the trailer, that's not so much of a concern. But things like, down to the safety chains, all those have to be matched to the capacity of the trailer, right? And then the gross vehicle weight rating is governed by the limitations on the capacity of the hitch, how much the tires can carry, those kind of considerations.
Okay.
Right? So mostly you're worried about DOT regulations. And the compliance verification program of the NATM helps manufacturers ensure, by having a biannual audit every other year of their compliance, that they're maintaining that quality, and they can apply the NATM decal
Gotcha.
to the trailer. It's not a sticker.
Yes, sir. Well, speaking of NATM, you served on their committees, correct?
Yes, I've been involved in their committees for the past 8 or 9 years.
Okay.
And I recently finished my first term on the board of directors
Okay.
of NATM.
Awesome. So what is NATM and what do they do?
It's the National Association of Trailer Manufacturers,
Okay.
and it is a nonprofit association of trailer manufacturers in the trailer industry, making sure that we are promoting trailer safety by encouraging all members to build their trailers to minimum manufacturing specifications and meeting the requirements of DOT and those kind of things. And we have the NATM has a set of guidelines that they put out on a periodic basis. It's not necessarily every 2 or 3 years, but it does get updated regularly. And it has the recommended minimum best practices for trailer manufacturers to follow.
Okay.
And the Technical and Compliance Committee, their job is to review those guidelines and update them as needed. And if the guidelines need to be reissued or updated, they're responsible for making sure those are all up to date with current regulations.
Okay.
If there's any improvement in best practices, then they'll incorporate those as well.
Okay. Awesome. So, is that kind of do y'all do that with DOT and non-DOT alike?
Well, it's mainly focused on DOT.
Okay, gotcha.
Yeah.
So if they see that decal on there, what can the consumer be assured of?
Well, the consumer can be assured that the manufacturer is meeting the safety standards of the Federal Motor Vehicle Safety Act, and that their trailers are properly marked and certified for legal roadway use in the United States and in countries that recognize our safety standards.
Is there different regulations in different states, or is it kind of just the same?
There's different requirements for some states have different requirements for what constitutes a safety chain, whether the trailer needs to be inspected annually, what capacities are you able to haul. Some states have a little bit more stringent requirements on whether all trailers must have brakes,
Sure.
for example, or only if it's above a certain capacity, like 1,500 pounds, which is a magic number for boat trailers, for example. But so there's a little bit of juggling, but we have compiled in the NATM guidelines a list that gives you a reference to the difference between laws by state.
Okay.
So to help the manufacturers out.
Gotcha. Well, very cool. Is there what are some of the biggest compliance challenges companies are facing right now?
That's a good question. It's there are compliance issues that are kind of rearing their head in the form of legislation, or I shouldn't say legislation, but regulations that have been introduced by people who don't understand, for example, the difference between medium duty trailers and heavy duty trailers. That's to say, trailers at over 26,000 pound gross vehicle weight rating. And so the NATM is having to make the argument that medium duty trailers are not the same and shouldn't be lumped in with semi-trailers because they're just simply not the same. They're not pulled with a kingpin on the front, riding on a rub plate that's attached to a fifth wheel or locked into a fifth wheel, and they don't pose the same hazard to other motorists on the road that heavy duty trailers do by the nature of their size, right? So the industry the trailer industry is classified as a motor vehicle industry,
Sure.
even though there's not typically a motor driving the trailer. It's typically towed
Right.
by an actual, what we would say an actual motor vehicle is.
Right.
But under the law, a trailer is a motor vehicle.
Gotcha.
So it's lumped exactly in the same categories as a car.
Oh, okay.
And it's a challenge because that's been that way for a long time. So it's one of the things that we have to, as an industry association, the NATM has to watch out for undue burdens of regulation that just get thrown out there by
Sure.
people who like to write laws without knowing exactly what they're writing. So,
I understand. Yes, sir.
so
Okay. And who usually handles the I guess the best term for it is lawmaking of those compliance rules?
well, the representatives and senators who are on transportation-related committees
Gotcha.
will be the ones that are introducing legislation. And they don't those representatives and senators don't necessarily write the legislation themselves. That's often written by their aides and their staff,
Sure.
right, who are perhaps lawyers, perhaps not, but they write the legalese to make it a legislation
Sure.
or an act that can be passed into law. One of the biggest problems is that it's often not just legislation that comes into play, but regulations by the Federal Motor Carrier Safety Administration and in combination with the Pipeline Hazardous Materials Safety Administration for hazmat materials. Now, Wylie doesn't build hazmat haulers, but if that regulation gets lumped in there, then we can have unintended consequences, and we just have to keep our eyes out. But we pay, we have lawyers that we're contract with to keep an eye on the Federal Register to make sure those things, when they do pop up, can be addressed in a timely
Sure.
fashion.
Okay.
So,
Very nice. Is there a difference between commercial regulations and residential?
well, when you get into commercial type regulations, you have to have you have to be able to drive a commercial motor vehicle.
Sure.
Right, so over 26,000 pounds in most states. It's when vehicles in combination get over that amount, then the consideration becomes how much rating can the trailer have, because that's the only variable in the equation
Sure.
between a vehicle and a trailer, and you add those together. Well, the vehicle really doesn't change. It's designed to do what it does. Trailers have different capacities.
Right.
So if you need a 14,000 pound GVW trailer instead of a 16,000, so that you don't cross some gross vehicle weight rating line, then you would design down to that rating in order so that you don't break any laws,
Sure.
if that makes sense.
Yep.
Okay.
Absolutely. Keeping it legal.
Yeah.
I understand. So, so how do you? I mean, you briefly touched on it with that statement, but how do you balance being creative with the designs and still following the rules?
I guess the important thing is just consider what the limitations are.
Sure.
And then try to maximize your abilities within those limitations. Yeah, I guess that is the best way to put it. I'm not sure if I'm answering your question there.
Yeah.
Okay.
Okay. So, what about AI? Has that made its way into your field of work yet?
In some ways it has, because when you do modeling, right, with solid models, and you have you can see that something interferes with something else. And some of the programs out there can make a suggestion
Sure.
based on the how things fit up, right? That here's some of the ways this could be solved. They're not going to say this is what you got to do.
Right.
They just say here's some of the options that you could consider in order to solve that problem.
Okay.
And so it is built into some of those programs, and also from an ERP, that is to say, or I don't know what the best term there is, but enterprise resource planning is what I mean when I say ERP.
Okay.
So that encompasses the use of parts and labor and vendor parts and materials and overhead and all the things that go into there, to say that, based on the current pattern of usage of these number of frames, you're going to run out in 2 months, but it's going to take you 3 months to build enough of them. So you need to start,
Yeah.
So we see AI kind of incorporated in those type of programs in order to maximize the ability to do just-in-time manufacturing,
Gotcha.
where you're not building something that you're going to have money tied up in a year in advance of needing it,
Right.
but you're not going to wait so light to start it that you don't have it when you need it.
Right.
Right. So you get it just in time. And the money that you have to invest to do that is not tied up for any longer than it has to be.
Gotcha.
So
Okay. So more regulation, suggestion type arenas.
right.
Gotcha. Okay. Well, to kind of wrap it up here, in your opinion, what separates a good engineer from a great engineer?
Probably 3 things just off the top of my head. So one thing is to be able to put the effort in to make something work that's user friendly. It can take a lot of thought to make it operate simply. And my mentor used to say, it's really easy to make things complicated, but it can be really complicated to make things easy.
Right.
And so just putting the thought into solving a problem such that it's not impossible to use, right? And so sometimes that means you have to dig a little deeper and think about how things can be used in their proper application, right? And then make it easier for the operator to do it.
Right.
So it's not hard on the surface. The second thing is the ability to communicate right? So one of the quotations that's always been a favorite of mine is from George Bernard Shaw, and he said, "The problem with communication is that there's always the illusion of it happening." Right?
Okay. Yeah.
So you can look somebody right in the eye and tell them, and they can nod their head, and they had no idea what you said.
Exactly.
But so to be a better engineer than not means that you put the information that you need to communicate down in a method that's easy to understand,
Sure.
right? And if it's easy to understand, then it's easy to follow. And if it's easy to follow, then it's easy to do, right? But you don't have to read my mind, so there doesn't have to be an illusion of communication, right? You just have
Yeah.
to read what I wrote, but I have to go to the effort to write it,
Sure.
right? And it has to make sense when I do. So the first part is design, the second part is communication, and the third part is never assume as an engineer that you know more than the guy on the floor,
Okay.
right? Because they're the ones that actually put it together, whether it's a welder that's welding the parts, or it's the guy who's assembling it after it's painted. In my experience, if you run into some kind of issue, getting their input on how they would solve it can give you a jump start in order to not make it complicated, right? Because those guys, since they build stuff for a living, they often have a lot of common sense. And engineers, maybe as a rule, don't, they think in theoretical terms naturally.
Sure.
But a welder and assembler, they have to think in practical terms because they have to work with what's in front of them, right? An engineer can come up with great ideas and they look fantastic on screen or on paper, but does it work, right? So if I don't assume that I know more than the guy who actually puts it together, and if I get his input on what's a good way to do this, then it makes for a better design to begin with, right?
Sure.
So those would be the three things. Putting the effort into thinking about something, communicating it clearly, and then don't assume that you know more than you think you do.
Those are good life lessons too.
They are.
Absolutely. Well, and that goes back to simplicity is always better, in my opinion. Yeah,
For sure.
absolutely. In all aspects. So looking forward 10 years or so into the industry, what are some of the positive things that you're looking forward to, and there's some advancements coming up, or just some things that you're noticing?
There's probably a general trend, I would say, toward standardization more than customization. But there's always going to be a need for customization. The trick is going to be, can you do customized things in an affordable way? Because not everybody wants the exact same thing off the shelf, right? They want it almost like that, but with, like an extra feature. And is there a simpler way to do that? And how do you go about accomplishing that? So how to customize without being a total custom shop is going to be a challenge for the industry, I think.
Yeah.
The more standardized that things become, the more you can do things like robotic welding, right? Where for standard parts, you can put things into a fixture after they've been tacked up, and then a robot can weld them out. And then your guys can take care of the custom stuff, right? Because if you're stamping out a standard trailer over here that you can spend time customizing, with
Sure.
the guys who can put the touch to it. So AI is not going to replace welders.
No.
That's never going to happen. AI is not going to replace assemblers when custom assembly is needed.
Sure.
It just doesn't work that way. So
Yeah, that's too difficult of a field, I think.
right.
You need that human hands-on experience to
Yeah.
to make it really, really good.
Yeah.
Absolutely. Well, do you have any words of wisdom or any final message to anyone looking to getting into engineering or design?
Probably the main thing, piece of advice I'd have for somebody who wants to become an engineer is that you need to understand that as you go through school and take the engineering classes, all you're doing, and this is the most important thing, you're not learning how to apply skills. You may even have no idea what you're going to be designing, right, or what kind of job you're going to take. What you should be learning is learning how to learn. What you should be doing is learning how to ask good questions. You should be learning how to communicate, and you have, because when you get out of college, you don't know anything. You think you know a lot.
Yep.
But what you have are some basic skills, and now you got to apply them in the real world, right? But if you're able to learn, then you're able to learn how to apply those skills effectively. And sometimes, not all the time, I don't mean this as a stereotype, but sometimes young people assume that they know a lot.
Yeah.
And they really don't.
Right.
They don't know anything about anything, and they don't know what they don't know.
Right.
But if you start out understanding that you don't know anything, you're a lot better off, right?
Yes.
So,
absolutely.
From that standpoint, I would say, don't assume that you know. You don't know.
Yep.
You're going to learn, but it's important to know how to learn.
Right.
Right. The second thing is to be able to get along with people. You are never, and I mean never, the most important person in the room.
That is true.
Right. And never assume you're the smartest.
Right.
You might be the smartest, but it's better if you don't think of yourself
Right.
that way.
Always good to practice a little
Right.
humility.
You always want to learn from what other people know.
Right.
Because everybody has something to offer. And you can always use pieces of knowledge to improve how you do your job.
Right.
And then, just the third thing, and probably this is more important than anything, is just to have a good attitude. Right. Yes, it's sometimes tedious to do the work.
Yeah.
The reason they call it work is because it's work.
Exactly.
Right? But you're there, right? I mean, you're in a career that you get the opportunity to solve problems that, as you mentioned, people don't even know they have
Right.
sometimes. But if you've learned to ask the right questions, then you can solve those problems, and people can go, well, that's a cool invention. I didn't know I needed that, but I know I now.
Right.
I'm glad somebody thought of that. So that's kind of the cool part of engineering, is you're able to solve problems that people don't know they have before they know they have them. So.
Absolutely. But yeah, I definitely relate, because I didn't start out in agricultural design either. I
Right.
started in designing signs, and that's a whole different ball game.
Right.
Yeah, and we had some of those that they came fresh out of college, and they just wanted to they want to tell you how to do it, a different way, and it's
Right.
just like, yeah.
Right.
This is a whole different deal, man, and it's so unique to different industries. I think it's just unique to companies too.
Yeah.
Everywhere you go they have their own methods, they have their own systems, and like you said, if you learn to learn, you can adapt.
Exactly.
And the more you're able to adapt, the more valuable you become.
Yeah.
You know.
That's what enabled me to, and I've worked in 3 completely different industries
Right.
over the course of my career, and I intend to work for at least 10 or 12 more years. But they're all tied together. They're different. They're all different, but all tied together in that they all involve manufacturing,
Sure.
right? And manufacturing is the ability to take raw materials and turn it into something that's useful.
Right.
It's either useful to industry or useful to people. And if it's useful for industry, then it's useful to people by
Absolutely.
definition. Because you're either selling to consumers or you're selling to businesses who make things to sell to consumers, right?
Absolutely.
And so nobody thinks about heat exchangers, but you have to have them.
Right.
You've got to heat up water, you've got to heat up chemicals in order to produce reactions, in order to generate electricity, that kind of thing. People don't think about acid transports, but you want the acid to be able to be hauled over the road without
Right.
anything happening. You want it to be moved from one place to another safely over the highway. And the same thing is true about trailers. We need them, but people don't often think about them.
Right.
And so the industry exists, and even with the upcoming Trailer Safety Week in the first week of June, to kind of remind people that it's important to operate trailer safety, safely, I should say.
Right.
But in all those cases, we're building something, taking something that was just raw material, putting some effort into it, creating something that people or the industry that we're in can
Yep.
use,
Absolutely.
and it helps everybody. So
Oh yeah. Well, and
that's the best part about manufacturing.
absolutely. Well, and it's the reward of knowing that what you helped produce,
Mhm.
people benefit from.
Yep.
And you got to participate in that process, and it's just it's enjoyable.
Right.
It's fulfilling in some manners,
Right.
So, well, I'm gonna open up the floor to you if there's anything else you wanted to add in.
Well, I appreciate you having me on the podcast today.
Yeah, absolutely.
And I've been at Wylie for about 10 years. I don't know if you mentioned that, but it's been the best 10 years of my career. And I could not have picked better people to work for and with. It's absolutely just a privilege to be a part of this organization. So,
All right, sir. Mr. Michael, thanks for joining me.
yes, sir.